When fixing overhead light fixtures, several options exist to address the specific challenges presented. Firstly, consider recessed lighting fixtures designed for horizontal mounting within the steel plate. This approach maximizes headroom while maintaining a flush ceiling appearance. Secondly, explore modifying the existing fixtures by rotating the bulb sockets to achieve a horizontal orientation. This may involve replacing the sockets or adjusting the wiring configuration. The use of flexible metal conduit, or flex, to connect the junction box to the light fixture is an acceptable practice, providing it is installed correctly. Ensure the flex conduit is adequately supported using clamps or conduit straps every 3 feet to prevent sagging. Additionally, maintain a clearance of at least 6 inches between the flex conduit and any heat-producing sources such as light bulbs to mitigate potential damage to the conduit. Regarding the steel plate supporting the light fixtures, while it is unlikely to become energized under normal circumstances, it is recommended to bond it to the electrical grounding system as a safety precaution. Use a bonding jumper to connect the steel plate to ground, ensuring that any potential electrical faults are safely directed to ground. There are some additional things to consider as well. Firstly, confirm that any proposed modifications comply with all applicable local building and electrical codes. Secondly, consult with the club member electrician to ensure the chosen solution is feasible and safe. Prioritize safety at all times when working with electricity. Always de-energize the circuit by switching off the power at the breaker before performing any wiring modifications. To elaborate further on working with electrical systems and lighting, it's crucial to understand some fundamental principles. When dealing with electrical wiring, always ensure that the conductors are properly sized for the intended load. Refer to the National Electrical Code, or NEC, Table 310.15b16 to determine the appropriate ampacity of conductors based on their size and insulation type. Overloading conductors can lead to overheating and potentially cause a fire. Also, remember that electrical boxes must be sized appropriately to accommodate the number of conductors and devices they contain. NEC Section 314.16 provides guidance on box fill calculations to ensure adequate space for connections and prevent overcrowding. When working with flex conduit, ensure that you use the correct type of fittings and connectors. Different types of flex conduit, such as liquid-type flexible metal conduit, or LFMC, and flexible metallic tubing, or FMT, require specific fittings to maintain proper grounding and prevent moisture intrusion. Follow the manufacturer's instructions carefully when installing these fittings. Furthermore, when making electrical connections, always use approved methods and materials. Wire connectors, such as wire nuts or terminal blocks, should be properly sized for the conductors being joined and installed according to the manufacturer's instructions. Ensure that all connections are tight and secure to prevent loose connections, which can cause arcing and overheating. When bonding the steel plate, use a bonding jumper of appropriate size. The size of the bonding jumper is typically determined by the size of the circuit conductors feeding the lighting fixtures. Refer to NEC Table 250.102 current to determine the minimum size of the bonding jumper based on the size of the ungrounded conductors. Ensure that the bonding jumper is securely connected to both the steel plate and the grounding system using approved bonding methods, such as grounding lugs or clamps. Regarding lighting fixture installations, be aware of the different types of fixtures available and their suitability for different applications. Incandescent fixtures, while less energy efficient than other options, provide a warm, inviting light. Fluorescent fixtures are more energy efficient and provide a brighter, more diffuse light. LED fixtures are the most energy efficient and offer a long lifespan and a variety of color temperatures. When selecting lighting fixtures, consider the intended use of the space and the desired lighting effect. Also, be sure to comply with all applicable energy efficiency standards and regulations. Many jurisdictions have adopted energy codes that specify minimum efficiency requirements for lighting fixtures and systems. In addition to the practical aspects of electrical work, it's also important to understand the theoretical principles behind it. Electrical circuits operate based on Ohm's law, which states that the current through a conductor between 2 points is directly proportional to the voltage across the 2 points. Understanding Ohm's law is essential for calculating circuit parameters and troubleshooting electrical problems. Another important concept is grounding. Grounding provides a low impedance path for fault current to flow back to the source, which helps to protect people and equipment from electrical shock. The grounding system consists of the grounding electrode, the grounding conductor, and the equipment grounding conductors. The grounding electrode, typically a ground rod or metal water pipe, provides a connection to the earth. The grounding conductor connects the grounding electrode to the service equipment. The equipment grounding conductors connect the non-current carrying metal parts of electrical equipment to the grounding system. When a fault occurs, a fault current flows through the equipment grounding conductors back to the source, tripping the circuit breaker or fuse and energizing the circuit. Also, understand the difference between grounded conductors and equipment grounding conductors. Grounded conductors, also known as neutral conductors, carry current under normal operating conditions. Equipment grounding conductors, on the other hand, only carry current during a fault. Grounded conductors are typically identified by a white or grey color, while equipment grounding conductors are typically identified by a green or gray color. It is important to never connect grounded conductors to equipment grounding conductors, as this can create a dangerous situation. It's also important to understand the different types of overcurrent protection devices, such as circuit breakers and fuses. Circuit breakers are designed to trip and interrupt the flow of current when an overcurrent condition occurs. Fuses are similar to circuit breakers, but they operate by melting a fusible link when an overcurrent condition occurs. Both circuit breakers and fuses are rated in amps, which indicates the amount of current they can carry before tripping or blowing. When selecting overcurrent protection devices, it's important to choose the correct rating for the circuit being protected. Overcurrent protection devices should be sized to protect the conductors and equipment connected to the circuit. When working with electrical panels, always exercise caution. Electrical panels contain live electrical components, and contact with these components can be fatal. Always de-energize the panel before working on it, and use insulated tools to prevent electrical shock. Also, be aware of the potential for arc flash when working with electrical panels. Arc flash is a dangerous electrical explosion that can occur when a fault occurs in the panel. Arc flash can cause severe burns and other injuries, so it's important to take precautions to prevent it. Wear appropriate personal protective equipment, or PPE, such as arc-rated clothing, gloves, and face shields when working with electrical panels. Electrical safety is paramount, and it's essential to follow all safety procedures and regulations when working with electricity. Always de-energize circuits before working on them, use insulated tools, and wear appropriate PPE. If you are not comfortable working with electricity, hire a qualified electrician to do the work for you. Electricity is a powerful force, and it should be treated with respect. By following these safety guidelines, you can help to prevent electrical accidents and injuries. Remember, electrical work is not a task to be taken lightly. It requires a thorough understanding of electrical principles, safety procedures, and applicable codes. If you are unsure about any aspect of electrical work, consult with a qualified electrician. Your safety and the safety of others depend on it. In addition to the specific considerations for lighting fixtures and electrical wiring, it's also important to consider the overall electrical system in the building. The electrical system should be properly designed and installed to meet the needs of the building and comply with all applicable codes and regulations. The electrical system should be inspected regularly to identify any potential problems and ensure that it is operating safely and efficiently. Regular maintenance, such as tightening connections and replacing worn components, can help to prevent electrical failures and extend the life of the system. When planning any electrical modifications or upgrades, it's important to consider the impact on the entire electrical system. Ensure that the existing electrical system has sufficient capacity to handle the additional load, and that any new wiring or equipment is compatible with the existing system. It's also important to obtain all necessary permits and approvals before starting any electrical work. Many jurisdictions require permits for electrical work to ensure that it is performed safely and in compliance with applicable codes. Working without a permit can result in fines and penalties, and it can also create a safety hazard. By following these guidelines, you can help to ensure that the electrical system in your building is safe, reliable, and efficient. Remember, electrical safety is everyone's responsibility. By taking the necessary precautions and following the applicable codes and regulations, you can help to prevent electrical accidents and injuries. These principles apply whether the electrical system is 120 volts, 208 volts, 277 volts, or 480 volts. Always use properly rated equipment, wiring, and safety procedures for the voltage you are working with. Lastly, the information provided here is for general guidance only and should not be considered a substitute for professional advice. Always consult with a qualified electrician for any electrical work that you are not comfortable performing yourself.